Hi everyone and welcome. I am Dr. S. Kritika and in this video we'll give you a good idea of what polymer is and its classification. Let's get started. In this video we will be looking into significance of polymers, definition of polymers, degree of polymerization and classification of polymers. Modernization of a civilized society is dependent on the advancement of materials. The civilization started from the Stone Age, passed through the Bronze and Iron Age, that is the Metal Age, now has entered the age of polymers. Still, now the materials are of the above three categories and their combinations. The phenomenal growth of polymers is due to their versatility with respect to structure, properties, and their applications. In performance characteristics and application prospects, they offer novelty and versatility which are not found in other categories of materials. As a result of which, other categories of materials are being replaced by the youngest member, that is polymers. Almost all sphere of material applications because of its versatile with respect to properties, that is the monomers for polymers can be obtained from the resources like petroleum, forest or even agricultural. Polymers can be designed to have wide range of properties like flexibility, strength, heat resistance and chemical resistance, enabling their use in diverse applications. Its ease of processing and fabrication requires low energy for processing, and many polymers are lightweight compared to traditional materials. Synthetic polymers can be produced in large quantities at relatively low cost, making them accessible for various consumer goods. The ease of modification of polymers allows for tailoring their properties to suit suitable specific applications. The word polymer comes from the Greek word in which poly means many and mer means parts. So polymer can be defined as a macromolecule which is made up of small molecules called monomers that are chemically bonded together to form a long chain. So many monomers combined together to form a long chain unit is called as a polymer. The process of the formation of the polymer from the reactive simple molecules by the application of suitable heat and pressure and in the presence of suitable catalyst is called as the polymerization. The number of repeating units in a polymer molecule is called as the degree of polymerization. The degree of polymerization is important as it affects the properties of the polymer such as its strength, flexibility, density, porosity and solution viscosity. Higher degree of polymerization is usually better for mechanical properties like melting point and tensile strength. The degree of polymerization are used to determine the molecular weight of the polymer. The molecular weight of the polymer can be found out by using the formula molecular weight of the repeating unit, that is the monomer, into its degree of polymerization. For example, if 1000 molecules of the polyethylene combines to form a long chain polymer called polyethylene, then the number of repeating units in the polyethylene is 1000 and hence the degree of polymerization is 1000. Now, let us solve some problems based on degree of polymerization. First problem, a polymer has a degree of polymerization of 5000 and a molecular weight of the monomer unit is 44 gram per mole. Find the molecular weight of the polymer. First, let us write down the given data in the problem. That is, degree of polymerization is given as 5000 and the molecular weight of the monomer is 44 gram per mole. By using the formula, molecular weight of the polymer is equal to degree of polymerization into molecular weight of the monomer. By multiplying 5000 into 44, we get 2,22,000 gram per mole as the molecular weight of the polymer. Second problem, a polymer has an average molecular weight of 1,20,000 gram per mole and its repeating unit has a molecular weight of 100 gram per mole. Determine the degree of polymerization. So in this problem, they have given the molecular weight of the polymer as well as the molecular weight of the monomer. So by using the formula, degree of polymerization is equal to molecular weight of the polymer by molecular weight of the monomer. By dividing 1,20,000 by 100, the degree of polymerization is 1200. Now, let us see the classification of polymers. Polymers are classified into different categories based on their source, mode of formation, structure, thermal response, nature of monomer, type of repeating units, and physical properties. Let us discuss one by one. Based on the source, polymers are broadly classified into three categories: natural polymers, synthetic polymers, and semi-synthetic polymers. Natural polymers are the polymers that occur naturally in plants and animals. They are formed in nature through biochemical processes and are essential for life. For example, starch, cellulose, rubber, and proteins are natural polymers. Synthetic polymers are the man-made polymers produced by humans through chemical processes. They are designed for specific uses in various industries. For example, polyethylene, polypropylene, nylon, polyvinyl chloride, polyester, and Teflon are synthetic polymers. Semi-synthetic polymers are chemically modified natural polymers. They are derived from natural polymers but altered to enhance the properties or usefulness. Example, rayon, cellulose nitrate, and cellulose acetate are some of the semi-synthetic polymers. Based on the mode of formation, the polymers are further classified into addition polymers and condensation polymers. Addition polymers are also known as chain growth polymers, and which are formed by the repeated addition of monomer units that contain double or triple bonds without the elimination of any byproduct. This type of polymerization involves breaking of pi bonds in monomers to form long chains. Polyethylene, polypropylene, polystyrene are some of the examples of addition polymers. Condensation polymers are formed by repeated condensation reactions between monomer units with the elimination of small molecules like water, HCl, or ethanol. Usually involves bifunctional or multifunctional monomers that can react at more than one site. Byproducts are released during the polymerization process. Polyester, polyamide, that is like nylon, are some of the examples of condensation polymers. Based on the structure, the polymers are further classified based upon the line linear structural representation, tacticity, crystallinity, geometrical isomerization, and chemical constituents present. Based on the line structural representation, polymers are further classified into linear polymer, branched polymers, and cross-linked polymers. In the linear polymers, the skeleton of the polymer structure is represented by a simple line of finite lines. For example, linear polyethylene, polybutadiene. In which branched polymers, the structure can be represented by a line of finite line with a short or long branch lines. Example, glycogen. In the cross-linked polymers, the polymers are represented as a network structure or planar geometry like graphite or space network as in diamond. Example, bakelite. Polymers can be classified based on the symmetry of their molecular structure, which refers to the regularity or arrangement of the repeating units in the polymer chain. The symmetry of polymer chains greatly influences their crystallinity, mechanical properties, and thermal behavior. So, based upon the symmetry of polymers, the polymers are further classified into isotactic, syndiotactic, and atactic. So, in isotactic polymers, all the substituent groups, that is side groups, are arranged on the same side of the polymer chain in a regular repeating pattern. For example, in this picture, CH3 is the side chain which is attached on the same side of the polymeric structure, and H is attached on the other side of the polymeric structure. In the syndiotactic polymers, the side groups are arranged alternatively on opposite side of the polymer chain. See, in this picture, it's clearly shown that CH3 is arranged alternatively on the polymer chain. But in the case of atactic polymers, the side groups are arranged randomly along the polymer chain. See, it's not arranged either in the same side or on the alternate side. So 1H is here, after that CH3 is coming, and 2H, and after that CH3 is coming. So it is arranged randomly. Hence this type of polymer is called as atactic polymers. Third one, based on the crystallinity, polymers are further classified into amorphous polymers and crystalline polymers. Crystallinity in polymers refers to the orderly arrangement of polymer chains in three-dimensional lattice. The extent of crystallinity significantly affects the mechanical strength, transparency, density, and thermal properties of polymers. Amorphous polymers lack long range of order in their structure, meaning the polymer chains are randomly arranged without a regular repeating pattern, generally more flexible and often transparent or translucent. Example, polymethyl methacrylate, polyvinyl chloride. The second type is crystalline, which possesses regions where polymer chains are arranged in an highly ordered structure. Generally, it's stiffer, order, and more resistant to heat and solvents than amorphous polymers. Example, polyethylene, polypropylene, and polyethylene terephthalate. Based on the geometrical isomerism, the polymers are classified into cis polymers and trans polymers. In cis polymers, the side groups attached to the double bonds are located on the same side of the polymer backbone. That is, CH3 is attached on the same side. It's flexible and elastic due to irregular packing. Low crystallinity, often amorphous, used where rubbery and elastic materials are needed. Example, natural rubber and cis polybutadiene. In the case of transform polymers, the side groups attached to the double bonds are on the opposite side of the polymer chain. It's rigid and tough due to the regular packing. Higher crystallinity compared to cis forms, less elastic and more brittle. Example, trans-polyisoprene and trans-polybutadiene. And next is the based on the chemical constituents. Polymers are classified depending on the nature of elements present in the backbone or child chains. Based on the constituents present, it is classified into organic, inorganic, and organometallic. The polymers have carbon as the primary element in their backbone, with other elements like hydrogen, oxygen, nitrogen, etc. attached as substituents or called as organic polymers. Example, polystyrene, polyethylene, protein, cellulose, and nucleic acids. And the polymers which have a backbone comprised of elements other than carbon such as silicon, phosphorus, or sulfur are called as inorganic polymers. Example, polysiloxane, silicates, and polyphosphosins. The polymers which contains both organic and inorganic components in their backbone are called as organometallic polymers. Example, polysilanes, polymers with metal organic frameworks, and polymers with metal complexes. Till now, we have discussed about the classification based on the structure. So next, the classification based on the thermal response. Based on the thermal response, the classification is done as thermoplastics and thermosets. Thermoplastics are the polymers which can be repeatedly softened by heating and hardened by cooling. So they have weak intermolecular forces that allow chains to slide past each other under heat. They are widely used in packaging, containers, and various other applications due to their recyclability and ease of processing. Polyethylene, polypropylene, polyvinyl chloride, and polystyrene are some of the examples of thermoplastics. Next one is thermosets. These polymers undergo a chemical change upon initial heating, forming a rigid cross-linked structure that cannot be softened or molded by further heating. Cross-linking occurs during the heating process, creating a strong three-dimensional network. They are used in applications requiring high strength and height resistance such as coatings, adhesives, and composite materials. Epoxy resins, phenol formaldehyde resins, and unsaturated polyesters are some of the examples of thermosets. So this table shows the difference between the thermoplast and thermoset plastics. So usually thermoplastics are formed by addition polymerization, whereas thermosetting plastics are formed by condensation polymerization. So these are linear structure, whereas thermosets are cross-linked structure. Thermoplast can be remolded and reshaped any number of times, but thermosets plastics cannot be remolded or reshaped. Thermoplastics can be reclaimed from waste, but thermosets cannot be reclaimed from waste. Usually thermoplastics are soft, weak and less brittle, but thermosets are hard, strong and more brittle. Thermoplasts are soluble in organic solvents, whereas thermosets are insoluble in. Based on the type of repeating units, polymer can be classified as homopolymers and copolymers. This classification is useful to understand the chemical composition and structural arrangement of polymers. First, let us talk about homopolymers. Homopolymers are the polymers that are formed from only one type of the monomer. The same repeating unit is repeated throughout the polymer chain. It contains identical repeating units, simple structure, and properties depend on the nature of the single monomer used. Examples of this polymer are polyethylene, polystyrene, and polyvinyl chloride. Copolymers are formed from two or more different types of monomers. These monomers are combined in the polymer chain in various arrangements. It contains two or more different repeating units. Properties can be tailored by adjusting monomer types and ratios and more versatile in application due to adjustable properties. Examples are trans-polyisoprene and trans-polybutadiene. Further, depending on the arrangement of the repeating units in the structure of copolymers, the copolymers are further classified into four types: random, alternating, block, and graft. When two or more number of repeating units, say I and B, are arranged randomly in the chain of the polymers, they are known as random copolymers. See in the example, the molecule that is A and B is not arranged in a proper order. So it's given as AB and three A's has come, and after that 2B, 1A and 2B. And this type of structure is called as random polymer. Next one is alternating polymer. When two or more repeating units, say A and B, are alternatively arranged in the chain of the copolymers, then they are termed as alternating polymers. For example, in the structure AB, 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 so it is coming in a repeating units are alternatively arranged in the chain of the polymers. Then this example is an alternating. The third one is the block copolymer, in which the repeat units, say A and B, are arranged as block in the polymer chains. For example, see in the structure 3A is coming repeatedly, after that 3B and 3A. So since it is occurring as block, this is called as block copolymer. And next one is the graft. In this type of copolymer consists of two or more homopolymers in such a way that one homopolymer is covalently attached as a long chain branch to the backbone of the other homopolymer. See here in this structure, two homopolymers are there. One is A, other one is B. A is the backbone of the structure and B is forming as the chain from the backbone. Hence, this structure is called as the graft copolymer. Next one is based on the physical properties. Polymers are classified into plastics, fibers and elastomers. So polymers can also be classified according to their physical properties such as hardness, elasticity, strength and flexibility. These physical properties determine their practical applications and processing methods. The first one is the plastics. Plastics are rigid or semi-rigid polymers that can be molded into various shapes when soft but retain their form when cold. Example, polyethylene, polypropylene, polyvinyl chloride, polystyrene and bakelite are some of the examples of plastics. The second one is the fibers. Fibers are thread-like polymers with high tensile strength and high modulus. So high modulus refers to resistance to stretching. Example, nylon, which is a polyamide, polyethylene terephthalate, polyacrylonitrile, and aramid fibers are some of the examples of fibers. Third one is the elastomers, that is rubber. Elastomers are elastic polymers that can be stretched and returned to their original shape when the force is removed. Example, natural rubber, that is cis polyisoprene, synthetic rubber, silicone rubber, and neoprene. And in this session, we have discussed about the significance of polymers, what are polymers, degree of polymerization, and classification of polymers based upon different aspects. Thank you.